Now we'll discuss this resolution on proposition logic. Okay, refutation, resolution to refutation. Refutation is a method used to prove the given proposition alpha is logically entailed by knowledge base by deriving a contradiction. Contradiction, you can say that empty clause also. To prove that proposition alpha is true, resolution refutation uses contradiction. To show knowledge base entails alpha, we show that knowledge base and negation alpha is not satisfiable. Means we are not it is not having true values. Okay, we say that empty clause or we are having. Apply resolution to knowledge base and negation alpha in conjunctive normal form and resolve pairs with the complementary letters. So here there is one thing like L1 or Li or something and so on M1. So where Li and Mj are complementary literals. You see that Li is a negation P and Mj is P. So we are going to remove this entire thing and we are going to write a new clauses out of it. So we are going to add new clauses out of it, single clause at a time. So until there is no new clause to be added, two clauses resolve to the empty clauses, which means our knowledge base entails alpha. So that is what here it is given in a pseudocode. We'll just come to our simple problem. So we know that there's Umpus world. So Umpus world, let the agent is in the 1 comma 1, no breeze, so no pits can be in there. Now query was alpha equals to, is there any pit in P1 comma 2, meaning to find whether P1 comma 2 is safe or not. For that one, what you are going to say, the knowledge base alpha is equals to negation P1 comma 2 is R2 and R4. These are rules. So we are having rules already in our Umpus world. They also given these rules. They ask in the examination. R2 equals to breeze 1 comma 1 if and only, that is by implication P1 comma 2 or P2 comma 1. So what is the meaning of this one? If there is a breeze in 1 comma 2, 1 comma sorry 1 comma 1, there might be a pit in P1 comma 2 or P2 comma 1. That is the meaning of this one. And rule 4, there is no breeze in P1 comma 1. Okay. Now the knowledge base will become R2 and R4. Now the knowledge base we can rewritten as, what is the R2 rule? P1 comma 1 by implies P1 comma 2 or P2 comma 1 and negation B1. So right now we are using a resolution. What is the resolution means? The first thing and the first and foremost thing that you need to get is conjunctive normal form. What is this conjunctive normal form will does means eliminate or remove the biconditional or conditional. How we are going to do means, we are having some standard formulas. Alpha by implies B means alpha implies B and beta implies B we can write. And if it is a single implication means or conditional means alpha implies beta equals to negation alpha or beta we can write. So in the given knowledge base, we are having uh, by implication. To remove that by implication, what is the formula that we are going to use means alpha by implies beta, that is equal to alpha implies beta and beta implies alpha. Now alpha place we are going to substitute this part and beta place we are going to substitute in negation B11. So what we can write means B11 implies P1 comma 2 or P2 comma 1 and P1 comma 2 or P2 comma 1 implies B11. So and negation B1 comma 1. Okay, this is what our uh, equations after removing by implication. Next implication also we need to remove. So we know that well-known formula, if alpha equals to beta, sorry, alpha implies beta, then we can write a negation alpha or beta. So now what we are going to apply means negation we are going to apply for entire alpha. Okay, we are applying negation for entire alpha wherever there is p, then it will become negation b1 comma 1 or p1 comma 2 and negation of p1 comma 2 and p2 comma 1 or b1 comma 1 and negation b1 comma 1. So this is what after removing all our implications and by implication or conditional or by conditional. Next one, what we need to do means we need to apply De Morgan's law. Why we need to apply De Morgan's law means if there is negation outside of that any clauses, then we have to apply De Morgan's law and we need to send that inside. So if you are going to apply De Morgan's law, what it will become means here negation p1 comma 2 r will become and negation p 2 comma 1. So that is what here it is written. So negation p1 comma 2 and negation p1 2 comma 1. So this is what resulted. Now what is our uh, conjunctive normal form standard form of the equation? It is nothing but product of disjunction of literals or product of elementary sums. We are going to say like that, right? Now, to get into that form, we are going to apply distributive law. Where we are going to apply distributive law, you just observe once. Here we are having negation p 1 comma 2 and, so you should not have any kind of and over our clauses. We should be having over or only. So how we can write this one means, I'm going to take this one as a single statement and this one as a single statement. There's nothing but alpha and beta or gamma, you can assume. That can be written as a alpha or b1 comma 1, that is negation p1 comma 1 or b1 comma 1, and negation p2 comma 1 or b1 comma 1. So this is what actually they have written. And last thing is and negation b1, which is in the form of conjunctive normal form. Now to prove query resolution refutation using proof of contradiction, we have to take that knowledge base and uh, negation alpha is not satisfiable. We know that we are having this conjunctive normal form and we have to add our query to there. So that is and p1 comma 2. So entire knowledge base we are going to add negation p1 comma 2. So now we are going to take individual clauses one at a time. So after taking individual clauses one at a time, what happens means we are going to find the complementary literals or complementary elements. So first negation b1 comma 1, is there any b1 comma 1? Yes, it is there. So by combining these two, we are going to eliminate negation b1 comma 1 and just b1 comma 1. What is the remaining is p1 comma 2 and p2 comma 1 and negation p1 comma 1. So that is what we are having. Again, is there any combination of complementary literals? Means yes, it is the complementary literals, that is p1 comma 2 and negation p1 comma 2. So if you are going to erase this one, again we'll get negation b1 comma 1 and p2 comma 1 and b1 comma 1. Okay, so these are the elements that we got. Next, if you are going to check, is there any complementary? Similarly, you check this one, and at last we are going to get one empty clause where negation p1 comma 2 and p1 comma 2 we are going to get. If we are going to combine these two, we are going to get empty clause. So that is nothing but whatever the query that it is going to state here is invalid. If this query is invalid, originally our query will become valid. Why? Because we have applied a refutation, that is proof by contradiction. So this is how we are going to prove our uh, knowledge base entails alpha, that is our query, using resolution through refutation. Remember, this is for proposition logic.